Okay, so I'm going to share my screen. So just confirm if my screen is visible to you or not. Okay. So in our last class, we have completed development frameworks and APIs, right? In this class, let's talk about databases. So we have completed this thing, development frameworks. Why we use front-end frameworks, just not HTML. So I think you're not there at the last moment, right? In the last moment. Yeah. So we have covered this thing, right? So don't worry, this is a separate thing and database is a separate thing. So what you can do is you can simply watch our, yeah. So let's talk about database. Now we know what is databases, right? Database is used to store the information, right? So here we have the server. Here we have the server and we have databases. To store information, we have databases like MySQL, right? So we have types of a database. We have learned this thing, right? We have types of databases, MySQL, MS SQL, and this type of thing. Now we have to know what kind of data we can store in our databases. So we use database to store and manage structured data like user details and orders. In databases, we store data in tables with rows and columns format, right? And store and manage files like image, videos, right? Now we use databases to store user information or orders or other details. We use server storage to store files and folder images, right? And this type of large file. So this is the difference about database storage and server storage. In server we also have storage, right? But in server we don't store username and password like this. We store this thing in database. Why? Because it is so easy to retrieve the database entries, and we cannot store a large amount of data or a big file or big size of a data in databases. For that we use server storage. In server storage we store files, folder, videos, music, and this, right? Now here we have the key difference. Database database best for storing structured data that requires frequently searching and updating, such as a user detail or orders. And server storage, storing and effectively serving large files like image, videos, or documents. If you look a website that provides a video to download, right, there are chances that that thing is not stored in database, but that thing is directly stored on server storage. And this is how you download your file, whether it is a movie, video, or anything, in your computer or laptop, right? So here we have the real life example. Storing movie, we don't use database. Why? Database are not designed to handle large files. We use server storage, right? Now we have common database type. One we have is relational database, that is SQL. And then second one is NoSQL database, right? And third one is graph database. Okay, so these are the three common types of a database. Now here we have the difference. Each type of database has its own way of organizing and handling data, making them suitable for different kinds of application and data structure. We know that not every data is same, right? Some might to store numbers, some might to store email, some might to store special characters, number, and this type of thing. To store this type of data, we have three commonly used database. First one is non-relation. First one is SQL, that is relation. Second one is NoSQL. Third one is GraphQL. Now, let's talk about relational data. In relational database, always remember, in a relational database, we store data in tables, rows, and key format. So this is a table, right? So this is a table of user. Let me copy this. So we store data in rows and table format. Here, this is a table name. So what is the table name? User, right? And here we have the ID. Here we have username, first name, and last name, right? Now, here we have this key. So this ID is called key. Here we have different data, different tables, that is called post, right? Now, if you want to get the details of post, we can simply type this. In ID1, what user has post what thing? So it is here. So this is the user ID. User ID 1 post this comment, right, on this particular date, right? So this is how you know. And if you reverse back, you can simply know, acha, who is the person in this ID. You can see, acha, Jado is the person, John is the person of this ID. Got it? Any doubt here? This is the example of relational database. So ID is, yeah, so the ID table is related to this ID table, right? So user table is related to a post table. So here we have the relation, right? This ID1 represent the John, and this ID represent who post the content. This is what the relational database is. Is that clear? Perfect. And this is another example of relational database. Now, the relation between tables within a database is called schema. So this thing, so this is a table, right? Table 1 and table 2. The relation between this table is called schema. Okay, and using the ID we can make a connection to other tables. Yeah, and to establish the relation, we use the ID. This is our key, right? Using the ID, we can simply relate what user posted what comment. Here in user 2, so user 2 posted this thing. What is the name of user 2? So Alice. Yeah. And what is the post ID? Post ID is also 2. Yeah, so this is how it is relatable. Now let's talk about no relational database or non-relational database, that is NoSQL, right? So this is what the relational database. Let's see how the non-relational database works. This is the example of no relational database. So yeah, this is a user ID, name, email, and registration form, right? In this table, each row represents a user. Column like user ID, name, and registration date are used to store specific information about each user, right? So here you can see the difference. This is non-relational, huh? Now we have user ID, name, email, and registration date. Every data is stored here, right? But if you see the relational database, we only have the strings. Strings means we only have the characters here. Then in second table we have the numbers and characters, and this makes a relation. But here in non-relational database we have everything together. We have the name here, we have the email here, and we have the numbers here, right? So for particular user, every data is stored in here in this format, right? Now, before using a SQL database, you need to decide on what column you want to have in your table and what type of data the column store. For example, if you decide a column will store text or email, we have to decide, right? If I'm going to store a database, right? If I'm going to create a database, then I have to decide in this database what type of data I'm able to store: numbers, names, special characters, or what. Now, NoSQL database can manage various types of posts without requiring a detailed structure to be defined in advance. In NoSQL, now, let's say this is an example of a SQL database. Okay, this is an example of SQL database. Here, I create a database and I ask, okay, in this database, user can store characters, user can store special characters, user can store numbers. Okay, let's consider this is a SQL database. Got it? Now I have to define what type of data user can store in SQL database. But this is not the case in NoSQL database. A NoSQL database can manage various type of post without requiring a detailed structure to be defined in advance. We don't have to define it, right? For example, in NoSQL database, you can store posts with text, photos, videos, and comments without needing to decide exactly how each post will be structured before storing it. We don't have to. Now, in a SQL database, we have seen that data is stored on rows, tables, this type of format, right? Rows, tables, and columns. But in NoSQL database, there are 4 common storage model for NoSQL database. First one is key value, document base, white column, and graph. In SQL database, we have seen how our data stored using what? Using rows and columns, right? Using schemas. Similarly, in NoSQL database, we can store data in these 4 types, in these 4 columns, right? Or in these 4 types. Let's learn how it is. Now, we can store data like this. Is that clear? So we can store data like this. So here, we don't have to define or we don't have to decide what data user can store. User can store anything. Let's say this is the user 1, right? User can store their name, their age, their email address, right? And other things also. Here, we have post 1 to 3. Here we have the title, right? Now, to connect this thing, we have keys and values, right? As we learn here, data can be stored in these 4 formats or the common storage model, right? So let's talk about key and value. So key represents user 1 and post this, right? Value is object containing the user post and data. So what is the user key? That is user number 1, right? So if I search user number 1 using the key, I got this information related to user number 1, right? If I search post 1 to 3, I receive this thing, right? With the values, right? So this is how it contains. In this model, each key user 1 and post 1 to 3 points to a specific object with attributes like name, age, and email or title content. If I search post 1 to 3, I got this title, content. If I search user1, I got this, right? So this is how key value model works. Key and value model. Okay, so this is how we store data. Let's say here we have other example. Key is user1 and the post is this. Now this is what the document based model is. So document based model store data in flexible JSON like document. So this is also the same, right? But here we have the user ID, right? The key is ID. Inside that ID we have user1. This is a document based. Okay, is that clear? Any doubt here? Now you can simply check what is the difference here. In key values we have user1, right? Then we have all the details. Now in document base we have ID. This ID represent user1 and this thing, right? And we have the values. So here we have the value. If I search user1, I got this name, age, email address, and then post all together, right? But here if I type user1, I only got this name, age, email. If I type post, I got the post name. So this is what the document based model is. Is that clear? Now this is what the white column is. So everything is similar, but there is a small difference. White column database store data in column and not rows. They are good for large data set with different attributes. So we use white column model to store large amount of data, right? That is why it is used, and you can see both are in the JSON format. We use keys and values here to store the data, right? This model stores data where each key user1, post 123 link to an object with a specific detail about user and post. So it basically means that if I try to get the user1, I got this information with relevant this post, right? Is that clear? Now we have the graph. So this is how we store data in graph. Here we have the user1, user2, post1, post2, and here we have the relation. So this is what our relation is. Now here key, what is the key? User1, user2, post123, and relation1. This is the key, and here we have the value. Okay, in this model, key like user1, 2, post123, and relation1 each point to a specific object describing user, post, or relation between users. Is that clear? So this is how four types of column works. Four types of data model. So this is what the database is. Now we have the common web vulnerabilities. Now we have two types of developed application. One that we develop internally, and one uh, that we have publicly available, right? Now internally developed application is, let's say I have a group of software developers or engineers, right? I have group of people. They develop one application, right? They develop one application. Now this application is only for my company, right? No one can access this thing. Got it? Similarly, we have the publicly available web applications or publicly available development frameworks. This is the internal developed application, and we have the publicly available web application. WordPress is publicly available, everyone can use it, right? And here we have Joomla and these other things publicly available, so everyone can use it. Now, as a pen tester, right? if we are performing a pen testing, or if we are testing a website, we have to check some things, right? Whether it is a publicly available website or it is a internally developed website. So if we did not find any exploit publicly available, any exploit means if you don't find any publicly available vulnerabilities in that application, then we can simply check some functionality in that. So we may try to find vulnerabilities caused by misconfiguration even in publicly available web application, right? And internally developed web application. Let's say we have this type of functionality, right? Token authentication, right? If I have a login page, right? It doesn't matter. It doesn't matter if the web page is designed internally or publicly, right? If I have the login page, I can simply try to hack the login page. Right? I can try to check how the login page works and how I can break it. I can try to bypass the access if I have some level of access. Let's say if I have an access of user and not admin, right? I can change that access user to admin. Let's see what it happens. Similarly, if we have file upload functionality, instead of uploading a file, I can simply upload a malicious script, right? Or malicious file that can simply hack the web application. Is that clear? Hello? Yeah. Similarly, if we have any web application, we can try to run the command, right? Let's say we can try to do command injection. So basically in command injection, we learn how to run the operating system level command from the browser or from the web application. Got it? In command injection, we can try to execute our command from website to the operating system. So we know what is backend, right? So backend is a hardware and operating system, and in backend we have everything, right? And if we run our command to that operating system, then we can harm that web application, right? We can delete the web application and whatnot. And we have the SQL injection. Let's say if we have a database, we have just learned, right? SQL, NoSQL database. We can try to get the information. We can try to dump the information from SQL databases. Is that clear? So this is the functionality we can do this. Okay. Then this is our last thing, that is publicly available vulnerabilities. Now, publicly available vulnerabilities, we have the backend components, right? So backend components here. So we have the backend components. Let's say whatever backend components we have learned so far, whether it is a PHP, SQL, MySQL, right, and some kinds of APIs, we can try to search the version of that. We can try to search the version of that application, right? And use Google to find any exploitation. Let's say if our website use PHP 7.8, right? I can simply go in Google, simply type exploit DB, then a PHP 7.8 exploit, right? So it doesn't matter. We have learned so many components of web application, right? So we just have to identify the version of that. Okay, once we identify the version, we can simply search exploit of that version if there is available exploit or not, right? If we find the exploit, then we can simply use like this. Okay, so we can search this. Similarly, yeah, we have the SQL injection. Then we have the vulnerability and exploit database. You can use exploit DB instead of this, right? Now we have CVSS. We have CVSS code. Let's say if you, yeah, let's say if you find a vulnerability, right? Whether it is a backend vulnerability, front end vulnerability, or using any component vulnerability, right? You have to give some score on that vulnerability, right? So CVSS means common vulnerability scoring system. You have to give the score on rate of 1 to 10, right? So uh, 1 to 2 means informational, and to 5.9 means medium, and 7 to 8 means high, and 9 to 10 means critical, right? So this is the score, and based on this score your vulnerability is categorized as critical, medium, low, this type of thing, right? No, low is low. We have the score. Yeah. So in CVSS code, whenever you are calculating the CVSS code, we have three things. One is base matrix. Now base matrix uh, measures how severe a vulnerability is based on characteristics. So using the base matrix, it identifies how severe a vulnerability is based on their characteristics. Then we have temporal matrix. So temporal matrix adjusts the base code of a vulnerability based on factors that may change over time. So let's say if you find a vulnerability in, just a second. Hello. Bye. हाँ ठीक है. हाँ सर. कौन सा सर? जी जी. हम्म. सर आपकी वॉइस नहीं आ रही. हेलो. एक मिनट सर, मैं चेक कर लेता हूँ ये आप कौन सा बोल रहे हैं. एक मिनट. GTMS ना, झारखंड. ओके. यहाँ पे है मेरे पास अच्छा, लॉग इन ब्रूट फोर्स का जो आप बोल रहे हैं ना, तो सर इसमें जो ब्रूट फोर्स है ना, इसमें बस पासवर्ड ब्रूट फोर्स है. तो इसमें मैंने ईमेल ब्रूट फोर्स नहीं किया. जो ईमेल है ना आपका, वो तो आपका इनक्रिप्ट होके जा रहा है, लेकिन पासवर्ड आपका प्लेन टेक्स्ट में जा रहा था, ठीक है. तो मैंने इसको URL इनकोड कर कर बस पासवर्ड को ब्रूट फोर्स किया है. हम्म. हाँ सर, तो इसमें क्या हो रहा था ना, जो पासवर्ड था ना मेरा, वो यूआरएल इनकोड होके जा रहा था, तो मैंने पासवर्ड को यूआरएल इनकोड करके दिया इसमें। जो मेरा ईमेल था वो तो इनक्रिप्ट होके जा रहा था, एंड जो पासवर्ड था वो पासवर्ड आपका यूआरएल इनकोड होके जा रहा था। तो मैंने जो अटैक लगाया है ना, नहीं वो इनक्रिप्ट नहीं हो रहा था, तो मैंने जो अटैक लगाया है ना, अटैक में मैंने जो मेरा पासवर्ड है उसको मैंने यूआरएल इनक्रिप्ट करके यूआरएल इनकोड करके सेंड किया आगे। नहीं, उसके लिए तो फिर राइट पासवर्ड चाहिए ना, मैंने सक्सेसफुल लॉगिन का तो मैंने नहीं लिया। मैं बस अटेम्प्ट कर रहा था कि ये कितना रिक्वेस्ट ले रहा है। मैं इसमें बस अकाउंट लॉगआउट पॉलिसी का ये देख रहा था। हाँ सर, करेक्ट तो आपने दिया है। नहीं, एक्चुअली मेरा मेन मोटिव क्या था ना, जो ईमेल था वो तो इनक्रिप्ट होके जा रहा था, तो ईमेल पे तो मैं नहीं डाल सकता था, ठीक है। मेरे पास दो ऑप्शन थे, या तो मैं इसको रेट लिमिट पे दे दूं, या तो को मैं ब्रूट फोर्स पे दे दूं। फॉरगेट पासवर्ड का मैंने रेट लिमिट पे दे दिया। अब इस पे मैंने एक चीज़ नोटिस किया, जो पासवर्ड है वो तो यूआरएल इनकोड होके जा रहा है, वो तो इनक्रिप्ट होके नहीं जा रहा है, ठीक है, या तो वो प्लेन में जा रहा है। तो मैंने क्या किया, मैंने बस पासवर्ड को ब्रूट फोर्स करने का अटैक। हाँ सर, मैंने चेक किया था, यहाँ पे आई गेस कि मैंने दूषित दिया होगा ये। अ, सर मैंने इसको चेक किया था, आप बोले तो मैं रिकन्फर्म भी करके इसको एक पीओसी दे दूँ, बट ये सेम ही था। एंड यहाँ पे सर जो ये टोकन लगा हुआ है ना, मुझको लगा ये टोकन के थ्रू वेरीफाई होगा पर रिक्वेस्ट, बट ये टोकन के थ्रू भी वेरीफाई नहीं हो रहा है। या फिर मैं इसको क्या कर दूं सर, को दूं या ना दूं, क्योंकि इसमें हिट तो हो रहा है। अगर आ, यहाँ पे मैं आपको एक पीओसी सेंड करता हूँ, आप इसमें एक बार पासवर्ड को देख लीजिएगा। हाँ, नहीं आप ना ये ऑप्शन मेथड इनेबल है ना, वो एक बार पीओसी ओपन कीजिएगा। इसमें आई थिंक कि आपका ये, हेलो। हाँ सर, ये आप ऑप्शन मेथड वाला एक बार पीओसी ओपन कीजिए ना, इसमें ये मेरे हिसाब से यूआरएल इनकोड होके जा रहा है, बट शायद ये इनक्रिप्ट होके जा रहा है या यूआरएल इनकोड। ये तो ये आपका, तो सर इसको क्या करूँ, इसको हम्म, तो हमें तो सर नो नो लॉकआउट पॉलिसी डाल दीजिए इस पे। ब्रूट फोर्सिंग नो लॉकआउट पॉलिसी इसमें डाल दीजिए, क्योंकि रिक्वेस्ट तो जा रहा है, हिट हो रहा है। लॉकआउट पॉलिसी का कोई मैकेनिज्म है नहीं इसमें। हम्म। मैंने ओके। हम्म। हाँ मैं समझ गया, लेकिन हाँ ठीक है, वो मैं समझ गया। इसका एक ये है कि ईमेल राइट था, लेकिन ये इनक्रिप्ट होके जा रहा था, तो उसका पीयूसी मैंने नहीं लिया। जो वो था, यहाँ पे डायरेक्ट ईमेल जो है वो इनक्रिप्ट होके जा रहा है, उसका है पीयूसी। ओके, गॉट इट। ओके ओके। तो हम इसमें ओके आंसर, वो जो नो रेट लिमिट था उसका उसका तो अलग ही देंगे ना। ओके सर। ओके, थैंक यू सर। ओके, आई एम एक्सट्रीमली सॉरी। हाँ, so we have the temporal, right? So temporal adjusts the base code. So let's say that if we have a vulnerability here, right? Let's say the database is totally vulnerable. Now, where is the database? Database. So we let's take that the server is totally vulnerable. You find a vulnerability publicly, okay? You find a vulnerability in internet and you attack the server, right? Now, every company asks you what is the CVSS code. You have to create this code. You have to identify, okay, what is the damage of this server. If the server is primary server, if the server is main server, if the server is main server, then the damage is high or critical, right? Is there is any patch available? Patch means any fix available of for this vulnerability. If yes, then your CVSS code is always low, right? So it adjusts. Temporal adjusts the base code of vulnerability based on factor that may change over time. The factor include patches are available to fix the vulnerability. If you attack the database, it's okay. So it's range from 0 to 10. If the server is main server, then the number is high. But if there is available patches, available fix to fix this issue, then it adjusts based on this, right? Then we have environmental metrics. So environmental metrics customize the score based on your specific situation or environment. They consider things like how important the affected system to your operation, what security measures you already have in place, and how vulnerable your organization is. Say, environmental metrics simply measures, is this your main operating system, your main server? What if it crash? What is the impact for your business? Yeah, and how long this server use the vulnerable component? Do you have other system that use vulnerable or outdated component? And based on these three things, we calculate CVSS score, right? And you don't have to calculate it manually. We have the calculator, right, to do this. Got it? So how to calculate? So the base score, temporal adjustment, and environmental adjustment. Start with number like 8 based on the serious vulnerability. The factor considered if patches are available. Look at how the vulnerability affects your system. We have this. Why we use CVSS? Because CVSS, if you use CVSS, it decides what to prioritize, what to standardize, and what to do with risks management, right? So here we have the CVSS code. CVSS version 2 rating, severity, and here we have the base code. So low, 0 to 6.9, medium 4 to 6.9, high this thing, right? Now we have two types of versions: CVSS version 2, CVSS version 3. In version 2 we don't have critical things, right? But in version 3 we have the critical things here. Yeah. Hmm. Which one? Hmm. So that is the CVSS code. Yeah, here it is different. I told you 1 to 2 it is informational, right? Now we have to understand, we are talking about CVSS 2. In CVSS 2 we don't have informational, we have low, medium, and high, and this is what the score is. But nowadays we are using CVSS version 3, and here we have informational, that is not impactable, so we can simply rate it using 1 and 2, right? We have low, we can simply rate it uh, 2 to 3 or maybe 4, right? So this is what the score is. Now it is totally based on the ratings, right? The calculation we do. For medium it is 4 to 6.9, for high it is 7 to 8.9, for critical it is 9 to 10. Got it? Is that clear? Yeah, you can watch the videos and make your own notes, right? And I'm going to tell you how to calculate the CVSS score. So before that, let's talk about the backend vulnerabilities. Now we know how to calculate the CVSS code. We know what is CVSS code, right? So here you can just go this link, and here you'll see CVSS thing, right? So here we have this thing, base matrix type of thing. This is how to change this. We have all this thing. I'm going to share this link. I'll share you in the group. Okay. Now let's talk about backend vulnerabilities. So backend vulnerabilities, we have the web server, right? And web server responsible. How the web server function? Web server main job is to handle incoming request and response. This is what the responsible. Now, backend server also use some kind of different software, right? So backend server create a different programming language or framework to handle web application logic, data processing, user authentication, and dynamic content generation. We can find vulnerabilities in backend components, right? So we have the external vulnerability. Attacker can get into backend server or network using various methods during external pen test. So attacker exploit weakness in external internet facing a database component of the backend server, such as outdated software version, misconfiguration, or weak authentication. So here what we can do. So we have the Apache, right? We can find vulnerable versions of Apache. This is also software. This is also software, right? and we can find misconfiguration in this firewalls, and if we have load balancer, then we can find this, right? So these all are the components of a database, and we can find vulnerabilities, right? And this is the internal pen testing. So internal pen testing is conducted within a company's network by authorized. So to do internal pen testing, companies invite you, right? They give you the access of their private network, and you have to find the bug in their private network. Okay. So this is what the internal pen. Now to calculate the CVSS code, what you have to do is you just have to go CVSS calculator. So here we have the CVSS calculator, that is version 3, right? Now here we have to give the base code matrix. We learn what is base code, right? What is temporal code and what is environmental. So in base code we have the attack vectors. Let's say the attack is network level attack, and the scope is attack complexity is high or low. You attack the network, right? So what is the complexity? Let's say it is high. What is the privilege required? Let's say I don't require any privilege, right? So what is the user interaction? Do you use user interaction? I say no. Then I have to set the scope, change, and then impact. What is the impact of the damage? Let's say high. What is the integrity? We know what is integrity, right? We have talked this in our first class. Let's say that is low. What is the availability of impact? Let's say that is high. That is change, right? So here we have this thing. So base score, we don't set temporal, we don't set environmental. Overall score is 8.4, right? So this is what our CVSS code is. Now, if we set temporal and environmental, it simply goes down. We have the temporal, you can set the temporal, right? You have the environmental, you can set the environmental. It show you the score. Let's say to the temporal, we have the proof of concept available. Add not define RDLX. Let's say this. Now external environmental score. Let's say is the network, right? And attack complexity high. Privilege required not defined, right? And defined. And here let's consider this low. And now we have set temporal 7.4. So this is what the total CVSS code is, right? No, not 6.9, 8.4. It is the overall CVSS code. So the base code is this, right? The overall CVSS code, it's the 8 point, the overall score is this. Now, so based on base code, what the base code is. Now, if we set temporal and environmental, we'll get this thing, right? And in our CVSS code, we have to put this. Now we know how to calculate this, right? So I highly recommend you to practice this thing. Got it? So how did you find today's class? So I highly recommend you to do the calculation. And our next thing is using web proxies, right? So in using web proxies, we learn how to use the web proxies, how to intercept the request, right? So this is what we're going to learn next class. Okay. Yeah, Monday or maybe Tuesday. So thank you for joining the class.